Hello everyone, ever looked around and just felt like you're standing on a flat surface? I mean, it makes sense. We use flat maps to navigate, right? A flat piece of paper representing the world around us. It's no wonder some folks, way back when, thought the Earth was flat. But, as most of us know now, that's not quite the whole story. We're actually living on a giant sphere, like a massive beach ball with some bumps for mountains and things. This surface, where we can move north-south or east-west, that's what we call a 2D space. But what other kinds of spaces could we be living on? Think about it. What if, instead of a beach ball, our world was shaped like a giant donut? That surface, too, is a 2D space. Mathematicians, through a field called geometric topology, they're actually studying all the possible spaces in all dimensions. And this isn't just theoretical. It helps in designing secure networks, mining data, even deploying satellites using origami principles. Now, let's zoom out. Way out. When we look at the universe, it seems like a 3D space, just like the Earth's surface seems 2D to us. But could the universe, as a whole, be something more complicated? A gigantic 3D version of that beach ball, or something even weirder? Remember that donut, or torus, as mathematicians call it? It is still a shape that you can move across in two directions. Mathematicians have spent over a century figuring out all these 2D spaces, and in recent decades, they've learned a ton about possible 3D spaces, too. We don't have all the answers yet, but knowing these possibilities helps physicists and astronomers try to figure out the actual 3D shape of our universe. And the options, they're intriguing, surprising, and they get even more complex when you consider time as a fourth dimension. To locate something like a comet, you need 4 numbers, 3 for its position and 1 for when it's there. That's a 4D space. So, which 4D space do we live in? Now you might think, why bother with anything more than 4 dimensions? But some theories, like string theory, suggest there are many more dimensions than we can easily imagine. And there are practical uses, too. Imagine planning the movement of robots in a warehouse. To describe the positions of just 3 robots, you already need 6 numbers, a 6D space. The more robots, the more dimensions. Add in obstacles, and it gets even more complex. This is where high-dimensional topology becomes essential. Another fascinating area topologists study is how one space can fit inside another. Think of a knotted loop of string. That's a 1D space, the loop, inside our 3D world. These are mathematical knots, and they're surprisingly important. They're key to understanding 3D and 4D spaces, and they have applications in everything from string theory to DNA recombination. So, what shape do we live on? Geometric topology is a beautiful, complex field, and there are still so many unanswered questions. What's the simplest closed 4D space? How do knots in 3D relate to surfaces in 4D? Topology is already incredibly useful in science and engineering. And as we unravel more of these mysteries about spaces, in all their dimensions, we'll gain a deeper understanding of our universe and unlock solutions to real-world problems. It's a journey of discovery, and the possibilities are truly infinite.